All right, so we're going to talk about dividing polynomials, and we're going to talk really about three different ways to do this, depending on what it looks like to start with. So let me start by talking about when we divide by a monomial. Now, just as a reminder, monomial means one term, okay? So, and it could have multiple variables in it. A monomial could look something like this, or this. Those are monomials, okay? There's no addition or subtraction between them. It's just a coefficient, possibly variable, okay? But no, they're just one term and one term only, so that's a monomial. So when we divide a polynomial by a monomial, there's kind of a little different rule than whenever we do regular division. And remember, we talked about, before we left, we talked about addition, subtraction, multiplication, and I told you we would get to division, but it was kind of sticky, and so here we are talking about division. So here's what we do. This is probably the easiest thing to do, is when we divide by a monomial. So we have this polynomial, let's say 6x to the 4th y cubed plus, and remember, this is recorded, so you can pause, rewind, fast forward as you see fit or as you need. I would highly advise you to be taking notes just as if you would if we were in class. And that way you have this to go back and reference. You can go back and rewatch the video or whatever it is you need. Okay, so I've got this polynomial, and I am going to divide it by 3xy. Okay, and so when you're dividing by a monomial, what you want to do is you just want to split this up into separate fractions, so that then you can simplify and use your properties of exponents the way you know. So what I would do here, and this is just a property. I don't want you to get caught up in oh my gosh, how come I can do this? This is just a property of fractions that we can do whenever we have multiple parts in the top. Now, if we were adding or subtracting down here, this wouldn't work, but because we're adding or subtracting, we've got this polynomial up top, and there's just the monomial in the bottom. That's why this works this way, okay? All right, so let me show you. 6x to the 4th y cubed, I'm going to put that over 3xy. Think about when we were doing quadratic formula, and we split that fraction up and it went to both pieces. This is the same kind of concept here. Minus 18x squared y over 3xy. And so now each of these fractions can get simplified on their own. I guess I can give you some little steps over here. So we'll say the first thing we do is split up the fraction, and then what we're going to do is simplify each fraction on its own. I know y'all can hear that clicking of my pen. I apologize. Okay, so here, let's look at the coefficients in front first. 6 divided by 3 reduces to 2, right? I've got 4 x's and 1 x, so if I divide, that means I subtract. 4 minus 1 is 3, and again, subtract with the same base here. 3 minus 1 would be 2. So this is a property of exponents problem, again, once you get it split up. Okay, on to the next one, plus 12 divided by 3 is 4. 3 minus 1 is 2. And 1 minus 1 would be 0. Those just cancel out. And then minus 18 divided by 3 would be 6. And these are nice because they simplify down to where there's not a fraction left. So that's good. 2 minus 1 is 1. And again with the y's here. Okay? And so there we have it. It's all divided and simplified. Pretty easy. All right, let's talk about, though, let's get a little bit, that's kind of a little bit of a review, but a little bit new. Let's talk about if we have, actually, let me show you one that's not quite as nice and neat. Let's say I had, let me pull one from here. homework here. Let's say that I had 28 c squared minus, well, come on. Let's do c cubed. D squared minus 21 CD squared. Let's see, divided by, actually, let me show it to you this way. Let's say it was times 14 CD to the negative 1. Okay, now understand this is still a division problem, and I want you to see why. When you see this negative 1 exponent, remember what that means. That means make it into a fraction and move it, right, to make it positive. So what I'm going to do is I'm going to make this part into a fraction, because this is in parentheses. All of it is going on the bottom of the fraction. So this is over 14 CD. Notice I'm dividing by a monomial. So what I want to do is split this fraction up, okay? I have 28 c cubed d squared over 14 cd minus 21 cd squared over 14 cd. All right, so 28 divided by 14 reduces down to 2, right? So now I get 2 is 28 divided by 14. 3 minus 1 would be 2. And 2 minus 1 would be 1 minus. Now here's where it's a little bit different, 21 over 14. Both of these I can divide by 7, right? And I would get 3 and 2. The c's are going to cancel, and 2 minus 1 would leave me with a 1 up top. So it's okay to still get a fraction when you divide. Sorry guys, there's no problem getting a fraction. That is a-okay to still have a fraction in your answer whenever you divide. All right, so let's talk about long division, because that's what everybody's ready to get to. Yay, our favorite, long division. All right, here's the thing with long division. You can always do long division. It's one of those things that always works. It is sticky, it is messy, it is long, as is the name. But if you can recall how to do long division from back whenever you first learned in 3rd or 4th grade, the steps are exactly the same, only this time I'm doing them with polynomials instead of just numbers. So here's what we're going to do. I want to set up a problem alongside here and show you how it correlates to the regular long division of polynomials. Before I get started, let me just set up this problem real quick. Let's say I had, if I had the polynomial 5x to the 4th plus 3x squared minus 2. Okay, one thing you need to understand before we actually do long division is you have to understand placeholders. Okay, and what placeholders are exactly what they sound like. They hold the place of something. Okay, so for instance, in this one, I need to make sure I have all my exponents there. Okay, so here I've got 5x to the 4th, so I've got a 4th power, right? I'm missing a power of 3, so what I do is I hold its place with a 0, all right? I've got 3x squared, but I'm missing now this x term, so I hold its place with a 0 minus 2, okay? It's going to be really important as we go through long division that you understand everything you do with polynomials in polynomial long division. You need to make sure that you have a placeholder there should you need it, okay? All right. Another thing to remember from back whenever you did regular long division is there are different ways that I can set up a division problem as far as how to ask you to divide it, and you need to know what goes, for lack of a better term, what goes inside the house and what goes outside the house, right? So if I had 5 over 23, okay, that's one way I could ask you to divide, and I would know then that 23 goes on the outside and 5 goes on the inside, right? This number on top is inside, this number on the bottom is outside, right? Another thing to keep in mind, let's see, I could also write this as 5 divided by 23. Okay, and that would tell me where to put things. The other thing I want you to remember is that whenever you would do a long division problem, let's say I had 57 divided by 3, right? And I went in and I did 3 into 57. 3 goes into 5 one time, multiply around, I get 3, I subtract, bring down, oh, this is a terrible example. Let's say 571. I don't want it to be perfectly divisible. Okay, bring down the next term. 3 goes into 27 9 times. 9 times 3 is 27. And I'm running through this really quick, and I know that. But what I want you to see is when we get to this point right here, okay, this is what we call a remainder. And a lot of you will want to put an R1, or you'll say, oh, put a decimal up there. And actually, I need to put 0 here and say this goes in 0 times. But this is a remainder. It's what's left over, right? So another way to write a remainder is to write it as a fraction of what's out here. So actually, this would be 190 and 1 divided by 3. It's the remainder over what you divided by. And we're going to still use that same concept as we do polynomial long division also, okay? All right, let's set it up and let's go. Let's do x squared plus 3x. And if you have some colored pencils, this might be a good time to get them, because you just may need them to keep up with the steps here. As far as what it is we're doing, though, it's pretty basic. It follows the same exact steps as that long division we just did. All right, so what I'm going to do, I'm going to set up a problem over here. Let's say 735 divided by 2. Okay, same concept. So just like I would set this one up, 2 into 735, I'm going to do the same thing with my polynomial. X minus 5 goes into x squared plus 3x minus 40. Okay, now the first, all right, so over here I would say 2. What do I need to multiply 2 by to get to 7? And I hope you would say, oh, well, you would need 3, and you'd be absolutely right. I'm going to come over here to this problem, and I'm going to do the exact same thing, only I'm just going to look at first terms. What do I multiply x by to get x squared? Okay, notice I don't have any placeholders. I didn't need them this time. But as you look here, I hope you say, oh, well, I need an x, because you'd be absolutely right. We're going to try to keep everything lined up. This is going to be my x squared column, my x column, and my constant column, okay? So x times what gives you x squared, and we said that was x. So come back over to your problem over here on the side. The next step that I would do is to multiply, right? 3 times 2 is 6. So I'm going to do the same thing here. I'm going to multiply around. So x times x minus 5, and that's important. You have to understand that it's x times x minus 5. I'm multiplying by everything outside there, not just the first terms. Even though you just look at the first terms to start with, you multiply by everything when you multiply around. So I got x times x is x squared, and x times negative 5 is negative 5x. All right? Back over to your problem here on the side. After you multiply and right, then you subtract, right? So subtract 7 minus 6 is 1. I'm going to do the same thing here. I'm going to subtract. But I have to subtract everything. So now what I'm looking at is I'm going, okay, well, x minus x squared, that goes away. That cancels, right? 3x minus negative 5x, well, that's really like 3x plus 5x, so that gives me 8x. All right, back over to our other problem. We drop down the next number, which would be a 3, and our whole process starts all over again, right? What do you multiply 2 by to get 13? 6. So here, I'm going to do the same thing. I drop down the next term, that's minus 40. And what do I need to multiply x by to get 8x? And I hope you said X. I hope you said 8. And so that goes up top in the constants column. Okay? Multiply around over here, which would give me 12. Subtract and drop down. And I did that all at one time because I'm going to be a step ahead over here. So x times what gives you 8x? We multiply around. So 8x minus 40, right? 8 times x is 8x. 8 times negative 5 is negative 40. And so now we subtract. All right. So 8x minus 8x, that's gone. Negative 40 minus negative 40, that would also give me 0. So what this tells me is I don't have a remainder here, right? Now, if I go back over here to my other problem and I continue to work, 2 times what gives me 15? That would be 7. 14, subtract, I would get 1. So this is my remainder. So this would become 1 over 2, just like I showed you before. Same thing would happen over here. If this was not 0, but if this was a number, I would come over here and I would say plus whatever this number is over whatever I divided by. Okay. Now, I don't need it since I don't have a remainder. This actually went in evenly, and I have x plus 8. Okay. Now, this was a nice easy one because it did come out without a remainder, but you will have plenty that don't have a remainder. So let's look at another one. Let's see what happens and see if we can't get it divided. All right. Let's do a good one. Let's do x to the 4th plus x cubed minus 6x squared minus 4x, yikes, minus 4x plus 14 divided by x squared plus x minus 2. Okay, again, check for placeholders. I don't need any in this. I've got 4, 3, 2, 1, and a constant. My one that I'm dividing by, I am also good on. So what I'm going to do is set my problem up here. X squared plus x minus 2 goes into x to the 4th plus x to the 3rd minus 6x squared minus 4x plus 14. Okay, and let's start the whole process. This has so much repetition that it becomes so easy once you get the hang and you practice with it enough, okay? All right, x squared times what gives you x to the 4th? That would be x squared. Multiply that around. Again, it's got to hit everything, okay? So x squared times x squared is x to the 4th. X squared times x is x to the 3rd. X squared times negative 2 is negative 2x squared. I'm going to subtract this. All right, if you're a same, change kind of person, you can do same, change, but you would have to change everything here. And now I'm adding instead of subtracting. X to the 4ths cancel. X to the 3rds actually cancel. And now negative 6x squared and 2x squared would give me negative 4x squared. Bring down your next term here, 4x. And now do the process all over again. X squared times what gives me negative 4x squared? And I hope you said negative 4. And actually, I'm wrong. Let's put it in the right column. Put it in the column with the constants here, right? All right, so multiply around, and I get negative 4x squared minus 4x, and I'm actually, what I'm going to have to do, because negative 4 times negative 2, that's going to give me positive 8. I'm going to have to go ahead and bring down this second piece here also, since I had 2 terms that cancel out in the beginning, and that's okay. That's no problem. Remember, this is subtracting. Same change, 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 change. Those are gone. Those are actually gone again. 14 and negative 8 would be 6. And so 6 is my remainder. And because 6 is my remainder, I will come up here and say plus 6 over all of this. X squared plus x minus 2. Okay, so when you divide these two, you get x squared minus 4 plus 6 over x squared plus x minus 2. Let's see here. Let's do one more. Then I think you should be pretty good. Let's do let's do one that let's do x to the third plus 6x squared minus x minus 4. Let's say it was set up like the other one I showed you with the negative 1 exponent. So let's say x squared minus 1, negative 1. Okay? Remember, this just means that it's going to be divided. Okay? And the other thing I wanted to show you, and the reason I did this one, is because notice I'm missing an x here. So I would want to write this with the placeholders. So x squared plus 0x minus 1. Okay? And so now as I set this up, so I have x squared plus 0x minus 1 into x cubed plus 6x squared minus x minus 4. Okay? What do you multiply x squared by to get x cubed? It would be x, so it goes in the x column. Multiply around x times x squared is x cubed. X times 0x is 0x. And x times negative 1 is negative x. Subtract. First terms cancel. I have 6x. Ooh, my pen is glitching on me. I have 6x squared. These are actually going to cancel on me. And then, so I have plus 0x, bring down the next term. And now start all over again. What do I multiply this by to get 6x squared? That'd be 6. And multiply around 6x squared plus 0x minus, my goodness, minus 6. Alright, so now I subtract. And again, I didn't do it before, but you can do a same change everything kind of deal. These cancel. Negative 4 and 6 would leave me with 2. So here my remainder is 2. And again, I put it over what I divided by. And that's long division.